Okay guys, this is Miss Elkins and I'm here to talk to you about additive relationships. The last time we talked about multiplicative relationships, and multiplicative relationships included division, although right now we're mostly dealing with multiplication, but just know that multiplicative involves division. We just don't say dividative relationships. And the same thing is true with additive relationships. Additive relationships also include subtraction. So those two things are all encompassed. We don't say subtractative relationships, we just say additive, and that includes both addition and subtraction. If you have these notes, you should be getting ready to fill them out now as we go along. Write down everything that you see me write down. If you don't have these notes, just get a blank piece of paper and copy down and try to make sense of your notes on your own. All right, so let's talk about an additive relationship. In science class, students are measuring the mass of flasks with different amounts of liquid. Each flask weighs 40 grams. Below are the various masses of each flask in the liquid. Question. Well, let's look at these flasks first. We have flask A, which has 60 grams, flask B, which is 80 grams, and flask C, which is 120 grams. All right, so how many grams of liquid are in each flask? Well, we know that each flask weighs 40 grams, so A has a total of 60 grams. That means that there are 20 grams of water in flask A. Okay. Flask B has a total of 80 grams. Oh, sorry, I'll just put B like that. Flask B has a total of 80 grams, but the flask itself weighs 40 grams. So that means in flask B, there must be 40 grams of water. And then flask C has a total of 120 grams. So flask C would have to have 120 minus 40. Let's see, that would be 80 grams of liquid in it. So the flask itself weighs 40 grams and the total is here. So that means every time you add water, or if you subtract the 40 grams, that will tell you how much water is in each flask. Okay, so describe how you determine the number of grams in each liquid. Well, I determine that number by subtracting 40, the weight of the flask, from each total. Okay, so that would be an additive relationship. Even though we subtracted, it's still an additive relationship because we don't say subtractive. All right, so let's talk about what is an additive relationship. An additive relationship can be described by the equation y equals x plus a, or y equals x minus a. Either way, it's additive. It's an additive relationship. And y represents, as it always has, the input. I'm sorry, I said that wrong. The output. And we also now know that that's called the dependent variable. It depends on what's x. Okay, and then x, of course, represents the input. And now we know that's the independent variable. And then a is, of course, the constant, because if you're not adding the same number every time or subtracting the same number every time, that's not an additive relationship. It's because the value of a always has to remain the same in order to be considered an additive relationship. So like we did with multiplicative, let's write the equations that go with the tables. So here we have a table where we have x and y And in the middle, we have to figure out the process of how we're getting from X to Y. And there's already a big hint. We know we're adding or subtracting. So let's look. If we go from 0 to 3, how do we get there? Oh, we're adding 3. But you have to check them all, because sometimes a table will fool you. The first two will be one thing, and then the next one will be something else. Always check the whole table. So to go from 3 to 6, oh, that's the same. It's adding 3. To go from 4 to 7, again, the same, adding 3. To go from 5 to 8, again, adding 3. To go from 6 to 9, again, adding 3. Another way to tell that this is not a multiplicative relationship, because in a multiplicative relationship where X is 0, Y will also be 0. And in this case, that's not true, so that can't be a multiplicative relationship. All right, because you can't multiply something by 0 and get a number. It's always going to equal 0. So we now know that the process is Y, and we always start our equation with Y, equals X plus 3, because every time we have an X, to get to Y, we have to add 3 to it. All right, let's look at this other table. Again, we're going to look from X to Y and figure out the process. It's not that hard. If you go from 0 to 7, how do you get there? Well, you can multiply times 7. You have to add 7. If you go from 2 to 9, again, you are adding 7. From 5 to 12 is adding 7. From 9 to 16 is adding 7. And of course, from 10 to 17 is adding 7. So the equation Y equals X plus 7, because every time you have a Y, it's 7 more than the X that corresponds to it. All right, so that's how you write an additive equation. All right, let's turn this paper over to the back if you have the paper. And we're going to do the same thing we did with multiplicative relationships. We're going to do all the different representations of the relationship. There's the equation, a graph, a table, and then of course there's always going to be a word description. So let's look at the word description here, because that's the one thing that they gave us so that we can make the graph and the table and the equation from it. The industrial tech teacher told his class to add 2 inches to the length of each student's project. Oh, that's easy. So we're adding 2. We can write our equation Y equals X plus 2. And then on the graph, I'll zoom in a little bit to that. If the project was 0 inches, right? And you add 2, sorry, I didn't mean to make a dot there. If it was 0 inches and you added 2, well, of course, now the project is 2 inches long. If it was 1 inch long and you added 2, and now it's 3 inches long. Notice how I had to make my own 3, because there's not a line there, so but it's directly in between the 2 and the 4, okay? And then if you had a 2-inch project and you added 3 to that, 2 plus 3, oh, I'm sorry, we're not adding 3, we're adding 2. 2 plus 2 is 4, so that one is now 4 inches long. In a 3-inch project, added 2 would now be 5 inches long. And you can see it's going to go in between the line, on the line, in between the line, on the line, in between the line, on the line, all the way down to if you had a 10-inch project and you added 2 to it, it would now be 12 inches in length. All right? And then all we have to do now is to make a table. We can take these same numbers here and here and make our table. We have to sort out X and Y, and that comes from our table. X is the length, so we'll say original length. Original length. And now the new length. Or they wrote it as total length. New length, total length, same difference. So, and we'll just put in the numbers we want to put in there. If the original length was 0, the new length is 2. And if it was 1, now it's 3. And if it was 2, now it's 4. And if it was 3, now it's 5. And if it was 4, now it's 6. And we could put any numbers we wanted to in that table, but I just chose to go in order. But it wouldn't matter. It's still plus 2 to the x each time. So there you go. The relationship of y equals x plus 2 in an equation, a graph, a table, and a word description. All right, now the second example, they gave us an equation. So we have to come up with a word phrase that could represent adding 10 to x. As you can see, y equals x plus 10 is our equation. So something where we're adding 10. I've got a great idea. The math teacher, I'm not really doing this, but I'm going to put it in anyway. The math teacher added 10 points to each grade. We'll say test grade. Each test grade. That'd be great, wouldn't it? The math teacher added 10 points to each test grade. So now I got to come up with a graph that makes sense to go with that. Now, the highest grade you could make on a test would be 100, right? And of course, if the teacher added 10 points to it, it'd be 110. So if there's no test grade, there'll be no new test grade. So we can't add 10 points if you haven't got a grade, excuse me, already. So it looks to me like the original grade, I hope you agree with me. Oh, I can't write. The original grade will be our independent variable, and the new grade will be our dependent variable. So what we want to say is, let's start it. Well, if you have a grade of 0 and we add 10 points to your grade, then you're going to have a grade of 10. So let's go up on the y-axis by tens. Here we go. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. We're not going to be able to fit that 110 on the graph, but that's okay. We know it would be there. And we'll do the same thing on the y-axis. We'll start with a grade of 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And we graph that. If you made a 0 on that test and the teacher adds 10 points to your grade, then you're going to have a 10 for grade. If you make a 10 on the test, let's hope that doesn't happen. Now your new grade's at 20. And as you can see, that line's going to go up in a straight diagonal all the way. And if we had a bigger graph, it would go all the way up to 110. Because if you made 100 on the test, you'd now have a grade of 110. So notice that our graph does not, however, start at the point 0, 0. Because even if you made a 0 on the test, the teacher's still going to give you that 10 points. So you're never going to have a 0 on that test. No 0, 0 is going to exist in an additive relationship. Now, we've got to make our table. Table's easy enough, and we'll make it from the grade. From the graph. So we'll say original grade and new grade. And let's just start at 50. Let's say the lowest grade on the test was a 50. So if you made a 50 on the test, you now made a 60 because you added 10 to your grade. Or if you made a 60, now you're making a 70. Or if you made a 70, now you're going to make an 80. Or if you made an 80, you're now going to have a 90. Or if you made a 90, now your test grade is going to be 100. So you can see we're adding 10 each time to the x values. I hope those make sense to you. All right, one more example of an equation, a graph, and a table. And this time they gave us the table. So what we're looking at here is the original purchase price and the total cost. So here's what we're going to say. I'm looking at this graph and I'm seeing the original purchase price was $50 and it's now 0 because you can see the intercept here is 0. And then if you also look at if the original purchase price was $100, now it's $50. If the original purchase price was $150, now the total cost is $100. So it looks to me like they're taking $50 off of the price, no matter what the price is. So I guess if it costs $50, they're going to give it to you for free. The equation like that, the equation for that would be y equals x minus 50, because they're taking $50 off of the price. So we could say, as a word description, there was a $50 discount on each item. My first thought is, well, what if it's $25? Are they going to pay you $25, or are they going to pay you $25 to take it out of their store? Never mind, that's not that funny. Okay, so now we've got an equation, a description, and a graph, and all we need is a table. And again, we can make our table from our graph. Original price and total cost. I'll just make it directly from the table. So the X is the original price. And we're going to hope that they're not going to let you take anything out of the store and pay them for it. So we'll say if the original price was $50 and they take $50 off, then that's going to cost you $0. If the original price was $100 and they take $50 off, now you get it for $50. If the original price was $150, you will now get it for $100. If the original price was $200 and they take off $50, it's now $150. And finally, if it's $250 and they take $50 off, it's now $200. I just chose those numbers because they made the most sense to me, but you could have picked a lot bigger numbers. Just know that each time from each X, $50 is being subtracted to get the Y. All right? So I want to put one thing down here at the bottom of our summary, and it is additive relationships. Will not include the point 0, 0 on a graph. Okay, if there's a 0, 0 in there, that is not an additive relationship. Okay, well, I hope you got something out of this video, and I hope I will see you soon. Have a great day.